Hey guys, welcome to our extra practice video. I feel like this is like a, an after show after the show. You know what I mean? Like it's a one-on-one, just you and me doing some extra practice problems, having a good time. This typically tends to be a topic that students struggle on, calculating average atomic mass. So I wanted to work through some sample problems with you guys. And sometimes just the more you see a problem worked out, the more you understand it. So here's an example problem. And you can write down this problem on your notes. On the back of your 3.4 notes, there's a place for you to write down extra practice problems. So you can write down problem number 1 there. The first thing you want to do when you're calculating average atomic mass is you want to get your pen working. So let me get my pen working here. Okay, so we're calculating average atomic mass. And essentially, the formula for average atomic mass is you need a parentheses for each isotope. Okay. Here I see I have 3 isotopes. 1, 2, 3. One isotope is hydrogen 1. One isotope is hydrogen 2, and one isotope is hydrogen 3. Remember, those numbers are the mass numbers of the elements, of the atoms. Sorry. So each hydrogen atom has a different mass number. But you want to put the percentage as a decimal. And then you're going to multiply it by the mass number of that particular isotope. And then you add it to the percent as a decimal times the mass number of the other isotope. Okay? So this is essentially, you just continue doing this on repeat. All right, so let's go ahead and work through this problem. What is my 3 isotopes? I have hydrogen 1 is 99% abundant, hydrogen 2 is 0.8% abundant, and hydrogen 3 is 0.2% abundant. Just by looking at these, I can tell that hydrogen 1 is the one I have the most of. So I can guess that my answer should be closer to 1 than it is to 2 or 3, because I don't have a lot of 2 or 3. Okay, so hydrogen 1 is 99%. So I'm going to write it as a decimal. So instead of writing 99, I'm writing 0.99. Okay, 0.99 is my percentage moved as a decimal. And the way you do that is you take the decimal and you move it over twice, and then you get your percentage as a decimal. And I'm going to multiply it by the mass number. This is hydrogen 1, so I multiply it by 1. Okay, what's my second isotope? It's a mass of 2, and it's 0.8% abundant. So again, if I move the decimal over 2 spots, it's actually 0.008, and then I multiply it by the mass, which is 2. Okay, now I'm going to add that to my third isotope. My third isotope is 2% abundant, and so to find out what that is as a decimal, I move my decimal over twice, and it's 0.002, and then I multiply it by the mass of 3. And now I'm just going to put all this into the calculator. Okay, so I put it in parentheses 0.99. Let me show this to you so you can see it. Parentheses 0.99 times 1, and then I close my parentheses. And then I'm going to add it 0.008 times 2, close my parentheses, add it 0.002 times 3, close my parentheses, and then that's my answer, 1.02. And 1.02, we can tell, is very close to what I estimated. Remember, I estimated it to be 1. On these, you do not want to round. So you want to write down the exact number. 1.012 AMUs is my answer. Okay, let's do another practice problem here. Okay. This one, I'm given rubidium, okay, and, oops, I don't know what I'm doing. What am I doing? Okay. Rubidium is a soft, silvery white metal that has 2 common isotopes, okay. All of that's extra information. I don't need it. What are these 2 isotopes? Well, I can't see them because they're over there. It's rubidium 85, and it's rubidium 87, okay. So here's my formula. I know I have 2 isotopes, so I'm going to have 2 parentheses, okay. Remember, I have to move the percentage as a decimal. And so this percentage, if I'm going to write it as a decimal, has to be written hold hold on. Why is it being weird? Stop being weird. Stop being weird. It's being weird. Hold on. 0.802, and then I'll multiply it by the mass number, which is 85. So here's my mass number. I wrote it right here. Here's my percentage, and I wrote it right here as a decimal. Okay, now the next one. It's rubidium 87. Multiply it by what's the percentage of rubidium as a decimal. Again, move the decimal over twice. 0.198. If you need help, if you don't know how to write the percentage as a decimal, just take the percentage, divide it by 100, and then you get the percentage as a decimal. So if you're ever having issues, if you don't know how to write the percentage as a decimal, just divide it by 100, and that will give you the percentage as a decimal. So now I put this into my calculator. Again, I do the same thing. I do parentheses 0.802 times 85, close my parentheses, add it to 0.198 times 87, close parentheses, and I get 85.396 AMUs. Now, ask yourself once you get this, does this make sense? Does this answer make sense? Well, 19% of rubidiums are at a mass of 87. 80% of rubidiums are at a mass of 85. So it makes sense that my answer should be closer to 85 than it is to 87. And as I can tell, my answer is closer to 85 than it is to 87. Okay, so this next one, there's not a next one. Just kidding. Those are the extra practice problems. I hope that was helpful. If not, I'm not sure what to tell you except to come to tutorials and ask me specific questions, or you could always go onto YouTube and type in average atomic mass problems, and I bet there's a bunch of other teachers, maybe not quite as funny as I am, but you know, and I'm sure that they will help you to learn this as well. But please, as always, ask me if you need help. And that is it for this episode of 3.4 Extra Practice.